The Standard Model classifies the electron as a true zero-dimensional point particle. Under this premise, the electron possesses no physical radius and no internal structure. Packing a finite electrical charge and mass into a volume of exactly zero results in infinite self-energy. The assumption of a zero-dimensional particle creates an immediate physical paradox. Physicists resolve this through renormalization, a mathematical workaround where these infinities are manually subtracted from the equations. This procedure allows the math to align with experimental reality, despite the structural failure at the core of the model. Quantum electrodynamics, the theory describing these interactions, predicts the electron's measured properties, such as its spin and charge, with remarkable precision. However, the model offers zero physical explanation for why the electron possesses these specific values. This predictive precision masks an architectural void. Within the Standard Model, quantum properties function as mathematical labels bolted onto a point, rather than traits derived from a physical structure. One field theory operates on a different methodological commitment. It treats the electron's measured properties as physical fingerprints of an underlying geometric shape. OFT replaces the point particle with the electric monopolon, a finite, self-confined knot of electromagnetic flux. In this framework, all matter begins as a continuous energy wave that twists into a stable spinning loop. Mass, charge, and spin emerge as mandatory geometric consequences of this specific toroidal topology. These properties are built into the shape itself. To understand the nature of matter, we must reconstruct the electron in literal, three-dimensional physical space, moving beyond the abstract scaffolding of Hilbert space. The electron's core topology consists of a single wavelength of circularly polarized light, closing back on itself. This structure is defined by three distinct field components: an outward-pointing electric field, an inward-pointing magnetic field, and a continuous path of circulating energy. Electric charge is exactly quantized because topological closures must be whole integers. One complete closure equals the fundamental charge. This topology possesses a finite, non-zero radius. Because the electron occupies a specific volume, the electromagnetic field energy trapped within it remains strictly finite. This confined field energy provides the mechanism for mass. Inertia emerges from the trapped energy of the circulation, m equals e squared over c squared, removing the need for an external Higgs field. Simply giving the electron physical boundaries resolves the infinite self-energy paradox. Mass and charge become natural artifacts of the geometry. Geometry also dictates the behavior of quantum spin. While a standard sphere returns to its original state after 360 degrees, the electron requires a 720-degree rotation. When Paul Dirac first modeled the electron, his equations pointed toward the existence of internal nodal structures. Dirac mistakenly collapsed these structures into point singularities, infinitesimal locations where the physics appeared to break down. One field theory identifies these nodal structures as continuous magnetic flux lines. The electric field loops smoothly through and around this magnetic core. These magnetic flux lines manifest as a physical tether, connecting the electron to the surrounding vacuum field. Rotating this tethered structure 360 degrees twists the connection to the vacuum. Untangling the field lines and returning the system to its resting state requires a full 720-degree rotation. Spin 1/2 represents the mandatory mechanical constraint of a non-singular, tethered topological knot. The Standard Model relies on a bedrock principle known as U1 gauge symmetry. Modern physics treats this mathematical symmetry as a foundational law that generates electric charge and dictates the existence of the electromagnetic field. On a continuous topological ring, there is no absolute starting point for the phase cycle. Any of these 8 phase reference ribbons serves as an equally valid starting point for labeling the torus. Gauge symmetry is a mathematical encoding of this labeling freedom. It reflects the redundancy inherent in our description of the field, rather than acting as a physical generator of the field itself. Three-dimensional topology creates the charge. The gauge symmetry is simply a redundant map of that territory. The Pauli exclusion principle states that two identical fermions cannot occupy the same state. Standard physics postulates this as a rule without providing a physical mechanism. This mechanism is visible in the behavior of macroscopic vortex rings. Toroidal structures with the same circulation direction generate mutually repulsive field pressures. These pressures prevent them from occupying the same space. The internal structure of the monolon is geometrically limited. A double-cover torus possesses exactly two independent winding modes, clockwise and counterclockwise. Once both the clockwise and counterclockwise modes are occupied in a given orbital, the system reaches absolute topological saturation. No third winding mode exists to accommodate an additional particle. The Pauli exclusion principle functions as a physical limit of the geometry, rather than a mysterious quantum mandate. Placing the three-dimensional monolon into a gravitational field reveals the physical origin of its motion. One field theory defines gravity as a gradient in the refractive index of the vacuum medium, caused by the presence of mass. A zero-dimensional point particle cannot experience differential forces across a volume it does not possess. This is a primary failure of the point particle model. Because the monopolon has a finite radius, different parts sample different regions of the vacuum gradient. This creates a tank tread effect. The internal flux at the bottom propagates slower than the top, causing the structure to physically pivot toward the mass. The equivalence principle emerges from classical optics. Matter falls for the exact same reason a lens focuses light. Differential refraction steers the wavefronts. Standard quantum mechanics assigns two distinct wavelengths to a single point particle, the Compton wavelength and the de Broglie wavelength, leaving their relationship unexplained. In the one-field model, the Compton wavelength represents the literal geometric diameter of the resting electron, dictated by the equilibrium of vacuum pressures. When the electron moves through space, its internal cyclic rotation interacts with its forward translation. This interaction creates a spatial beat frequency. The de Broglie wavelength is this physical, rolling wavelength of the moving soliton. This redefines the double-slit experiment. The electron behaves as a continuous wave structure, propagating and diffracting through a lattice of other waves. By defining matter as a topologically protected geometry, one-field theory strips away the mystical interpretations of Hilbert space. The strangest quantum behaviors are revealed as the logical, classical mechanics of a structured vacuum.